Hi everyone, this is our progress report for our chatbot, and we'll be showing you our source materials for our chatbot and different progress in different areas of the chatbot. So for example, the large language model, the video extraction, PDF and or website scraping progress. So first we'll be going over our source materials. We decided to do the chatbot on clinical pharmacology, and this is from the NIH website. They have an online course for principles of clinical pharmacology. We decided to do this one specific course instead of all of these, just so that we could have a lot more materials and specific materials for this course. And this is more of like an introduction course, but it's also starting to get more specific and higher level. And so we wanted to use this course as our source. So from NIH, there are the syllabus, the course information, and also they have video lectures. You can access these video lectures on their website, but you can also find them here on YouTube. They have about 80 videos for principles of clinical pharmacology. They have an optional textbook that you can get online. We also downloaded this textbook and have started scraping data from it. And this is like an example PDF. This is like their syllabus that we will also be getting data from and training our chatbot with. Unfortunately, NIH does not have assignment resources available for non-registered people. So we decided to use MIT OpenCourseWare to collect example assignments such as like problem set, case discussions, reports, and also practice tests. And they also have lecture notes too. All of these are in PDF, and we've also downloaded these and have started scraping them. There is also a forum that we're planning to scrape data from. This is under biology forums, but these are for specifically pharmacology. And so we'll be scraping these to collect more data and training our chatbot with. And students also asked about career stuff, especially in such a field as clinical pharmacy. And so we can also scrape data from American College of Clinical Pharmacy and train our chatbot with this in case students ask about career opportunities. Okay, so these are our different sources of course materials. And we have bits of these in our raw course materials folder. This is syllabus and textbook from NIH, and then these are the MIT supplemental materials. We have assignments, exams, lecture notes, and also a supplemental textbook. All right, first we're going to show you some things that we started working on but haven't fully completed yet. First thing that we have is the Piazza.
We're going to run this fetch post.py, which fetch post from Piazza. So we're going to log in using our email and password to Piazza. So what it does is that it scrapes the post from Piazza. We're supposed to log in using our email and password, and after a successful login, we can just name the file that we want to like write Piazza to, and we do not want to include the .txt because it's gonna auto-generate for us. And after that, it is going to generate a txt file, basically including all the posts that we successfully scraped from Piazza. So after we finish this, we see that it has successfully scraped some of the posts from Piazza.
Next, we'll be showing our video scraping progress. So Frame Extractor takes a MP4 video and then it creates a folder called frames, and it will put all the frames from the video into this folder. These are frames from that video. It will output like it's reading new frames, and this is a normal output. It just basically shows that it's the end of like finding all the frames of that video. So this is just like a very simple frame extractor. And then the other like sort of basic code that we have is text extractor. And basically this one takes the MP4 file, it creates a audio .wav file. It's just like the audio part of the video, and then it creates a text file of the transcription of that .wav file. Once that is done, it'll create this, and this would be the transcription from that video. And this is the normal output for that. Okay, and then another one that we have was the YouTube extractor.
YouTube extractor, all it does in the basic sense is you put a YouTube video link, it transcribes whatever is said in that video link and in that YouTube video, and then it searches for the word that you're looking for. It's gonna be useful for the model if we ever need additional context about a certain word. And you can see that from that video, which talks a lot about coronavirus, you can see there's multiple timestamps where the word was said in the video.
And we've also started working on this code called OpenAI Whisper. Essentially, it takes that MP4 video, creates an MP3 file, and it will create SRT files that basically tell the time of certain phrases and when they appear. So for example, this phrase, it was transcribed from the MP4 file. This phrase would appear at this time. We've been playing around with it. Right now, it's been very slow, and so we haven't really made too much progress with it, but we are planning to continue working on it and hoping to use this as an alternative code for sharing the timestamps of the transcription of words. This is different from YouTube Extractor because YouTube Extractor just takes a link. It doesn't require needing to have the video file in your local machine. It just needs that link, and then it will get that search term that you're looking for, which is perfect for the NIH video lectures. But if we wanted to have those lectures in our local machine, we can also use the OpenAI Whisper code to create a similar timestamp for the local machine videos files. Okay, so that's video. We're going to show a little bit of the large language model. Right now, these two files are very similar to the Lab 6 assignment that we had, in that it currently uses the OpenAI embeddings and vector store so that it can just take in the different PDF files and then process it and then answer questions that the user inputs. So we're not going to go into too much detail about that. PDF extractor currently just takes in the PDF and puts the data from these PDF into MySQL. So currently, the MySQL database will look something like this. It will have the document name because there's different PDF files. So for example, this is from the textbook .pdf file. This is page 1 of that textbook, and there's currently nothing in that page 1, but there are other text content in other pages. And then optionally, we have the image path because some PDF pages have images, and we thought about having the chatbot reference images when answering students' questions, but we're not super sure we're going to keep this feature, but at the moment it's right here. So that's what PDF Extractor does. Right now we are working on these two codes, OpenAI Cookbook and also the automated OpenAI. So OpenAI Cookbook code takes a Wikipedia article. It will process it using the OpenAI models. In this case, this is GPT-4. And then you can ask a question to it and it will print out a response. So let's run that. Right now, the question is hard-coded, so it will just print out the answer right here. And depending on the model, whether you're using GPT-3 or GPT-4, it will have a slightly different response. And automated AI is just an automated version of that. Right now, OpenAI Cookbook only takes in one Wikipedia article. The automated OpenAI takes in a lot more articles because it takes in this path, which is the CSV that contains the embeddings and many more Wikipedia articles. And so we're using this to train and see how it's currently working. We just ask the questions again and see how well it does in terms of answering the questions based on all the articles that we've given it. Right now, it does have some mistakes when it's answering questions. We're still working on troubleshooting how we can fix that and how we can remedy when it makes mistakes. So we're hoping that we can use this and create a large language model that it will work best for our clinical pharmacology materials. And then our last area of progress is Wikipedia scraping.
I hard-coded the Wikipedia clinical pharmacology Wikipedia page, and it goes through the branch section, which contains sublinks to other pages like pharmacodynamics. You can see all these like links, and it just scrapes all of the paragraph, all the text from these sublinks as well. And it just outputs to a file. And that's it.
Yep, so this is our current progress for collecting data, scraping it, and putting it into a database. We're planning to migrate from MySQL to another database to store our data, and we're hoping to use that data, train our large language model, and have our chatbot start to work. Yep, this is our progress report, and stay tuned for more progress reports on our chatbot. Thank you.